Section 5.1 is rates of change and slope. I can find rates of change from tables, and I can find slope. Big ideas here. Ratios can show the relationship between two changing quantities, such as vertical and horizontal change. The slope of a line is the ratio of vertical change over horizontal change. And the slope of a line can be positive, negative, 0, or undefined. Rate of change shows the relationship between two changing quantities. When one quantity depends on the other, rate of change equals the change in the dependent variable y over the change in the independent variable x. It's our y's over x. The table on the bottom of page 294 shows the distance a band marches over time. And I have that here as well. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So here, we're going to check and see what our rate of change is in between each of these time periods. So, for the first one, I'm going to figure out my distance change, which means I take where we stopped minus where we started. Here, I get 260. And I take the ratio of my time here as well. We want the distance with respect to time, which means distance compared to time. My time change there is 1. And so I compare them 260 over 1, which gives me 260. And that's distance per minute. So feet per minute. I'm going to do the same thing between for my next time interval. So I'm going to check my distance covered in the next time interval, which is 780 minus 520. I subtract here and I get 260 as well. I compare that to my time interval, which here my change is 1, 3 minus 2. I can simplify there, and I get 260, and again it's feet per minute. My last interval here, I ended at 1040 and I started at 780. So to find my change, I subtract. I get 260. My time interval here is still 1 minute. And it's distance with respect to time. We find the ratio of them up here. Okay, our change in dependent over our change in independent. So it's our change in output over our change in input here, our change in distance over our change in time, which again is going to be 260 feet per minute. So we want to know, is the rate of change in distance with respect to time constant? And here, since it's the same every time, yes. What does the rate of change represent? It's how far the band went in a certain amount of time. Here, they went 260 feet in 1 minute, or per minute. So every minute, they traveled 260 feet. When the rate of change is constant, it can be represented with the graph of a line. The rate of change is the ratio of our vertical change, the rise, to the horizontal change, the run, between any 2 points on a line. So the rate of change is called the slope of a line. It tells us how steep it is. So here it's our vertical change, which is our rise, and we get that vertical change by comparing our y's, our outputs. Our horizontal change that compares our x's. It's our run. So it's our change in y's over our change in x's. Rise over run is like y's over x's. In example 2, we're finding slope from a graph. So we want to find the slope of each line shown in the middle of page 295. And I have them here as well. The pictures in the book are a little bit better, but we can still run with it. So slope equals rise over run. Remember, our rise deals with our y's and our run deals with our x's. So when we look at our graph here, from any 2 points on our graph, here we have 2 picked out. Our rise, moving from left to right, we read a graph just like we read a book, figures how far I go, up or down. So here, I have to go up 2 to get to the same height as my other point. So my rise is 2. My run then is how far I go to the right. And we can do the same thing backwards as well. We can start at our second point and make them both negative, but that gives us more to worry about. So here, to go from where my point is on the x to where my new point is my run. And if we look, I went 1, 2, 3 lines, so 3 spaces here. My scales are both by 1, so I keep them just how they are. My slope then is 2 over 3. Rise over run. And we want to keep our slope as a fraction here because we're eventually going to use that, and having it in this rise over run is going to be very helpful. Part B, same idea. We want to find our slope. So slope, again, is our rise over run. Rise deals with our y's, run deals with our x's. So our change in y, that's our height, our rise. And again, from left to right, so starting at my first point here, I actually have to go down 1, 2, 3, 4 to get even with the height of my second point. And if I go down, that's a negative 4. My run, I go 1, 2, 3, 4, 5 places. So my slope then, my rise over run is negative 4 over 5. Now give this a try. What is the slope of each line in the bottom of page 295, which I have here? So again, slope is rise over run. So here, rise deals with my y's, run deals with my x's. My rise then, to go from my left point to my right, I have to go up 1 spot, 2 spots. So my rise is up 2, which makes a positive 2. My run, I go over 1, 2, 3, 4, 5. So rise over run gives me my slope, and 2/5 is what we're looking for there. Same idea here in B. We're going to find our slope. And slope is rise over run. Rise deals with our y's, run deals with our x's. So here, I'm going to go down 2 over 1, 2, 3, 4, 5, 6. Now, we always want to simplify if we can. So here, we also could have used any point on our graph where it meets like at a corner or where it's easy to see. So I could have used that point as well. But if I didn't, if I just used the 2 red points here and we simplify, my greatest common factor between 2 and 6 is 2. so I can take a 2 out of the top and out of the bottom. And I get negative 1/3, which again, if we just went down 1 and over 3, it would also get me to our line. Take note, the slope formula on page 296. Here we have a way to find our slope using just coordinates. So if we don't have a graph, we just have points, we can still find our slope. Remember, to find change, we subtract where we are from where we started. And so that's what my formula is telling me here. Remember, rise over run was our y's over our x's. So it's our change in y, okay, over our change in x's. So here, to find our slope, it's our rise over run, which, since we don't have a graph, is going to be our change in y's over our change in x's. It does not matter which point you use, where. What does matter is that you're consistent. So whatever point you use the y value of first, you have to use that same x value first. Whatever point you use the y value second, you have to use the x value from that same point second. So here, I'm going to go ahead and say that this is y2. This is x2 and y2, and this is x1 and y1. It doesn't matter, again, if I label this point 1 or this point, as long as we are consistent. If I use the y first from one point, I have to use it first from both. So here, my framework is that I have a fraction, and in the top I subtract, and in the bottom I subtract, and then I plug in my values. So I have y2 minus y1 over x2, and since I used negative 2 first, I have got to use that 3 first, minus x1. Minus a negative gives me a plus. Here, I'm going to simplify and get negative 2 over 4. Again, I can simplify there even further. I can take out a common 2, which gives me a negative 1 over 2. Negative 1/2. If you used your points backwards, you got a positive 2 over a negative 4. And that's fine as well, because it still simplifies down to be negative 1/2. 1 over negative 2 is the same as negative 1 over 2 is the same as negative 1/2. So it doesn't matter which order we use there as long as we are consistent. Now give this one a try. We're finding the slope, which is rise over run. Rise deals with our change in y's, and our run deals with our change in x's. Now again, it does not matter which point you pick first, so I'm going to make this x1, y1, this x2, y2. Okay, we plug them in. My framework here is that I subtracted my numerator, subtracted my denominator, and I have negative 1 minus 3 over, since I use negative 1 first, I have got to use 4 first, minus 1. When I simplify here, I get negative 4 over 3, and that does not reduce, so negative 4/3 is my slope. And I'll finish in another video.